In this example, we're going to take a look at this word problem. The owner of an orange grove finds that if 26 trees are planted per acre, each tree yields about 576 oranges per year. For each additional tree planted per acre, the number of oranges decreases by 12. We're going to take a look at using a table, a graph, and an equation to figure out how many trees should be planted to maximize the yield per acre. So to get started, we would want to go through and make a table. I want to take a look at how many trees we have. And to start with, the owner said that if we have 26 trees, what we ended up with is about 576 oranges for the year from that tree, from one tree. So in this column, oranges per tree. So if there's 26 trees, we're getting 576 oranges. And that's for each tree. So in order for us to see what the yield is, the total amount of oranges, what we'd want to do is multiply those two numbers together. And if we do that, we end up with 14,976 oranges total. And then it says, if we add an additional tree per acre, then the oranges will decrease by 12. So if we add another tree, we have 27 trees. That means the number of oranges per tree is going to decrease by 12, so that would be 564 oranges. And if we multiply those together, we get 15,228. We would want to continue that table down for a ways so that we have enough points for us to be able to determine what type of equation to use. So I've done that already to save a little bit of time here in the video for you. So there is the first 7 going from 26 trees per acre up to 32 trees per acre. And you can see that our total oranges is changing each time. And we still haven't figured out the maximum yet. But this may not figure out the maximum for us very efficiently. What we'd like to do is have an equation that would allow us to do that. So in order for us to do that, we're going to have our calculator figure out that equation, but we need to know what type of equation that we need to build. Is this information in a linear sense? Is it going to be modeled with a straight line, like y equals mx plus b? Or is it a quadratic? Is a U-shaped graph going to be the best? What's going to be the best type of equation in order for us to have the calculator help us out with this? To do that, what we want to do is look at our differences. So to figure out if this is linear, we're going to do the first differences. We're going to take our total oranges here, and we're going to subtract them. You would want to do your value of oranges, whatever you happen to be looking at in this list, and then subtract off the previous one in order for you to come up with your first difference for each pair. So 15,228 minus 14,976, that is 252. And we would want to do that with each one of these values. So those are our first differences. If those numbers are the same or nearly the same, then we would have a linear function, and we would want to use a linear equation like y equals mx plus b to do our calculating for us. But those numbers are different, so we should do the differences again. We're going to do the second differences this time. We're going to go through, do the exact same thing, except we'll be doing it with the first difference numbers. So 228 minus 252, That's negative 24. And if you do that with all of those pairs of numbers, we do end up with a column here where the numbers are actually the same. They're not even close, they're exactly the same. If your second differences end up being the same number, then the type of equation that you should use is a quadratic. So we're going to use a quadratic equation based on our differences. We know that that model should be a much better model than a linear model. In order for us to have our calculator help us out with this, what we want to do is take the information in this table and put it into our calculator. In order to make that work, what we're going to want to do is identify which of those columns we're going to be using. In the original, they asked us to determine how many trees planted per acre should be used to maximize yield. So we need the trees and the total oranges. And we're going to plug those in as our x and our y values in our equation. So I'm going to take this column and this column and use those to have the calculator come up with our equation. In order for us to do that, here are the commands that we would want to go through and use. First, you want to hit the Stat button. The Stat button is right in the middle of your calculator. And then from there, you'll have these three options. You have Edit, Calc, and Tests. We want to edit. We want to go in and put the information that we just came up with in our table. So I'm going to hit the Enter button. You'll end up with some lists. I want to go over to list number 1, and then I want to be putting in these x values. So we're going to put x in list number 1. And then in list number 2, we're going to want to put in these corresponding y values. And once you have those in, then the calculator can determine an equation for a line that will fit that information the best. So once you have all your points into list 1 and list 2 for your x's and your y's, you want to quit and go back out to the main calculation screen. So that's the second button and then mode. That'll bring you back out to your main calculation screen. And then to have the calculator calculate this quadratic equation for us, we want to hit the Stat button once again. This time go over to the Calc menu in the middle and scroll down until you find the type of line that you want. So you could do linear, you could do quadratic, you could do cubic, there's a bunch there. We want a quadratic equation for this. You hit Enter. That will cut and paste the quadratic equation command out to the main screen, and you just hit Enter one more time. It tells you that your equation that we're going to be using is y is equal to ax squared plus bx plus c, and then it tells you what a and b and c are equal to. So that gives us our equation. So we have y is equal to, and in place of a, we're going to put in the number 12, so that's going to be a negative 12x squared. And then plus bx would be plus 888x, and then plus c. C is 0 in this problem, so this is our equation that we can use in order for us to maximize yield. When you go through and you take a look at this equation, we're going to end up with a certain kind of a graph. Let me get a new piece of paper here. I'll copy that equation down once again. So there's our equation. And if you take a look at our quadratic equation that we have, our value for a is a negative 12. When you graph a quadratic, you get a U-shaped graph. And what you end up with when you have A negative value for A is that your graph is going to be U-shaped, but it's going to be going downward. So it's going to be looking something kind of like this. On your x-axis, what we have is the number of trees. And on our y-axis, what we have is total oranges. We know that from our columns in our table. Our height represents our total oranges. We're trying to maximize the total oranges, so we are looking for the point that is the highest in our graph, which is going to be the vertex. And we have a way of calculating the vertex if we know our equation. This vertex here is an ordered pair, and the x-coordinate of the vertex, that is the opposite of b over 2a. So I'm going to use that formula to figure out the x-coordinate there. So the opposite of b over 2a, that's going to be the opposite of 888 over 2 times a. Negative 888 over a negative 24. If you go through and you divide that out, what you end up with for your x value is 37. So there's our calculation for that. So the x-coordinate here is 37, and our x's are our trees. So we need 37 trees in order to maximize the number of oranges. The question, though, was, well, that was the question, actually. It's 37 trees. If we want to know how many oranges that is, we would just take that and plug that in. So the number of trees we need is going to be 37. And if we wanted to know the number of oranges, we can take that 37, plug that into the equation. That would calculate the y value, which would give us the total number of oranges on this. So we're supposed to use a table, a graph, and an equation to find out how many trees per acre are to be planted. We do have our table here, and we figured out our equation, which helped us figure out our number of trees for this problem. In order for you to come up with the graph, I would just go through and use this XY table that we did and plot each one of those ordered pairs. You may want to also include 37 and the Y coordinate there by plugging that in, and then come up with your graph from there.